Hi, this is Mr. Warden. I'm going to do a short video on how to deal with this worksheet on calculating standard deviation. I've done a longer version if you'd like to see me walk through the steps more carefully. But for right now, I have created an alternate version in which we have duck weights again, and I've got 4.8, 6.2, 7.1, 5.6, 4.5, and 5.1, and 6.3 pounds for each duck. I have added those together, and I've got 39.6. So the first thing I need to do is, of course, calculate the mean. Now, my number of ducks I've got a sample of is 7. So I'm going to divide by 7, and then I'm going to get 5.7. When I divide 39.6 by 7, I get 5.7, rounded, of course. Now, once I've got my mean, now I need to take each one of these sample weights, and I need to get the difference from the mean. So I'm going to take that 4.8, and I'm going to subtract this 5.7. And let's see, and I get negative 1.1. I'm going to do the same thing with 6.2, and I get 0.5. And again, 7.1 minus 5.7 gets me 1.4, and 5.6 minus 5.7 is 0.1, and 4.5 minus 5.7 is negative 1.2, and 5.1 minus 5.7 is negative 0.6, and finally, 6.3 minus 5.7 is 0.6. Okay, I'm going to take each one of these differences, I'm going to square it. Now, when we get our next one here, this 0.5, we're going to square that difference, and you get 0.25. We square the next one. 1.4 squared is 1.96. 0.1 squared is 0.01. That's 1/10 times 1/10 is 1/100th. And then negative 1.2 squared gets us positive 1.44. Notice all of our squares are positive. That's part of the point of this. Then negative 0.6 squared is 0.36. 6.6 squared is 0.36 as well. And then we're going to add all of these up, and we get 5.59. Now, in order to get a standard deviation, we have to take into account that we're dealing with a sample. If we were doing it with an entire population, we would take the sum of all of these squared differences from the mean, and we would divide it by the entire population. However, we do not have that. We have a sample, and so we're going to account for the fact that we just have a small sample by taking the number of parts of the sample and subtracting 1. And that'll make the denominator smaller, which will make the overall fractions value slightly larger. So n minus 1 is 7 minus 1. Our sample is 7. 7 minus 1 is 6. Now we're going to get a first measurement called a variance. And the variance is the next step to getting a standard deviation. So the variance is going to be this sum of the squared differences divided by 6. And so we will get 0.93. Now, the final step is to get the square root of 0.93 to get the standard deviation. So the standard deviation is the square root of this sum of squared differences. I should say, with the square root of the quotient of this fraction, 5.59 over 6. 5.59 being the sum of the squared differences, 6 being the sample size minus 1. So we get that. We got 0.93, and now we have to get the square root of that. And we get 0.96, and that makes sense because 0.96 is approximately 0.93 is very close to 1. So if we're getting the square root of 1, we'd get 1. If we're getting the square root of something close to 1, we get something close to 1. So that is our standard deviation. And with that standard deviation, we can use that to figure out how spread out the population is. If we assume that we have a normal distribution, a normal distribution looks something like this. in the population. So over here are the high end, and over here is the low end. Right here is our mean. We can split this shape up, and like between here and here is going to be about 68% of all the ducks. So about 68% of the ducks are going to be but within one standard deviation of the mean. So our mean was 5.7 pounds for a duck. And that means one standard deviation is adding or subtracting 0.93, 0.96 pounds. So add 0.96 to that or subtract 0.96. And then we can go further, 2 standard deviations out to about here or here. We're going to have 95% of all the ducks should be within 2 standard deviations of this mean. So we would add 9.96 twice, so 0.96 and then another 0.96 in this way, subtract 0.96 and subtract 0.96. So you can add 0.96 times 2 to get to here. And same with that, subtracting 0.96 twice to get to here from this 5.7. And that'll get you 2 standard deviations away. That will be 95%. We can go even one more step, a third one. This curve goes off to infinity, by the way. One more, a third standard deviation. So 1, 2, 3.96 is that way, and 1, 2, 3.96 is that way. That is going to be 97.5% of all the ducks will be within 3 standard deviations of 5.7 pounds, the mean of the ducks. And I hope that was helpful.